Hi everybody, welcome back. Today we're going to look at section 9.C.1, which is trigonometric identities. So we're going to be looking at solving different trigonometric equations and expressions. And we're going to start off with some of the basic identities that we're actually a little familiar with already. So first of all, let's talk about simplifying some trigonometric expressions. Some things we already know. So we already know that, for instance, it says here that sine, cosine, and tangent of theta are all real numbers. So you can really just combine them like you do in algebra. So if I said 2 sine theta plus 3 sine theta, well, that would equal 5 sine theta, right? Because just like 2x plus 3x equals 5x, same idea. And then some other identities we already know are true, right? Like the sine squared theta plus cosine squared theta equals 1. That's based on the Pythagorean theorem, and we saw that when we started building our unit circle. So as a result of that, you then also know that sine squared theta could equal 1 minus cosine squared, and cosine squared equals 1 minus sine squared, right? That's just a different form. And then, of course, we always know that tangent of theta is equal to sine theta over cosine theta. So let's do a couple of examples real quick, just to get us into simplifying expressions. So what happens if I have 3 cosine theta plus 4 cosine theta? Easy enough. 7 cosine theta, right? And tangent of alpha minus 3 tangent alpha, well, there's a 1 in front of there that's implied, so this is going to be negative 2 tangent of alpha, right? And as it says here, 7 cosine theta and negative 2 tangent alpha as my two answers. Why? Because we're just combining like terms. That's all we're really doing there. So another thing I want to talk about is another topic we've already discussed is the angle relationships. And these are different formulas that are based on the unit circle that we've seen already. And I'm going to go ahead and draw that unit, draw a set of axes here to kind of demonstrate what it's talking about. So the first one says that sine of negative theta equals negative sine theta, and cosine of negative theta equals cosine theta. And where that comes from is this. Let's say I've got an angle theta, right? It's out to here, and that's going to have a cosine and a sine value. Well, sine of negative theta, so this is going to have a sine and a cosine, right? A sine, or we should say cosine sine, because that's the order that it's in when we write the point, right? We know this is going to have a cosine and of theta and a sine of theta, right? It's my x and y values. And what happens if I look at negative theta? So if I look at down here, which is going to be negative theta, then what happens? Well, sine of negative theta is going to be the negative sine of theta. That's what this is saying, and that's what the first expression is saying. But what about cosine? The cosine of negative theta is still going to be the same as the cosine of theta, right? Because the x value doesn't change as I go down and I flip it below the x-axis, but the y value changes. So that's where those first two expressions come from. Let's talk about supplementary angles, right, for the next one. So let me erase this all here. And the supplementary angle says, this first one says that sine of pi minus theta is equal to sine of theta, right? So here's sine cosine of theta, or cosine sine of theta. What about pi? And if I go minus theta, I'm going to end up right here, right? If I go pi minus theta, well, are these two sine values going to be the same? They are. This is still going to be sine of theta. Why? Because they have the same y value, correct? The second expression says that cosine of pi minus theta is equal to negative cosine theta. So if I do pi minus theta again, what am I going to get for my cosine value? Well, I'm not going to get cosine theta. I'm going to get negative cosine theta, because whatever cosine of theta is here, it's negative when I go out to that point. So that's what this one is saying. It's saying that cosine of pi minus theta equals negative cosine theta. And those are what we call our supplementary angle formulas there. The next one is the complementary angles. And this is actually established as well when we start talking about the unit circle and just the way we have our angles in a right triangle that are across from each other. So this one says that sine of pi over 2 minus theta is equal to cosine of theta. And likewise, cosine of pi over 2 minus theta equals to sine theta. And what that's really saying is, I'm going to demonstrate that in a triangle. If I have a right triangle and this is theta, well, this is going to be, this angle right here is going to be 90 minus theta, right? Because we know those two angles have to equal 90. And 90 is another name for pi over 2. Well, is it true that the sine of this angle right here is equal to the cosine of this angle right here? Yes, and that's what the first one's saying. Likewise, the cosine of this angle here of 90 minus theta is equal to the sine of this angle down here, right? Because again, opposite and adjacent and things like that as well. Opposite and adjacent versus opposite over hypotenuse versus adjacent over hypotenuse. So those are just some basic angle relationships between trig functions that are good to know so you can use those in equations. Let me give you a sample idea of some of the problems that we're going to see. So for instance, let's say I wanted to simplify this. Sine of negative theta plus 2 sine theta. Well, what do I know about sine of negative theta? Well, let's go back up here. Sine of negative theta, as we saw, is equal to negative sine theta. So I can replace that. I can say, well, I'm going to rewrite this as negative sine theta plus 2 sine theta. And if I do that, well, now I can simplify it just like I did. I have negative 1 sine theta and a positive 2 sine theta. That's just going to be 1 sine theta. So that's my first answer. Likewise, I've got cosine of pi over 2 minus theta and cosine of pi over theta. It'd be really nice if I could simplify those down just to a sine or a cosine of a single theta. Well, let's look at cosine of pi over 2 minus theta. Cosine of pi over 2 minus theta, well, that just equals sine theta. So I'm going to replace the numerator with sine of theta. And then cosine of pi minus theta, the bottom, well, I know cosine of pi minus theta is equal to negative cosine theta. So I'm going to replace that with a negative cosine theta. And you see, in both cases, I've just replaced the expression with what I know they were equivalent or equal to. Now, what can I simplify this to? Well, what does sine over cosine simplify to? We know from up here, sine over cosine simplifies to tangent. So I can just simplify that to tangent, but there is a negative here, so it's actually going to be negative tangent of theta. And that's it. So using our basic trigonometric identities and properties, as well as the different angle properties that we know, or angle relationships, to solve some problems. So that's it. What I'd like you to do is, there's the answers for the two problems I just did. But I'd like you to check out these problems in section 9C1. I picked out, these are all individual expressions that you need to simplify. I just handpicked some ones from each of the problems. Numbers 1, 2, and 3. And there's, looks like there's, 10 problems total. And if you have any questions on those, again, please make sure you post in the discussion boards or send me an email. And please remember to upload your assignment into eCampus as well. Thank you very much. Take care, and we'll talk to you next time.